Welcome, welcome to another year of Hogwarts.
Hey, all right. Well, yeah, welcome. I don't know if Pablo will show up today. This is our very first day, so it might be good if it's just you and I. So
Yeah.
maybe we even just have a conversation about the general plan here, and then the next week we can do what my thought is on how we can have these regular sessions. Sound
Perfect.
good? Okay, thanks. Um, so I did some research, and if we show within the same uh, Chrome browser, so just the different tabs. We play the video and we share our screen, not the entire screen, but just that browser. The audio should come through. I'm gonna look it up again for how that works because that will make it. I mean, that's what I hope to do in these calls that we record the video presentation. And so let me look that up again, and then hopefully you can share your screen and show the video. I can also share the link if you
So,
don't have it. Huh?
so it's pretty interesting. I don't remember if it was like this last time. If I share my screen right now with Brave, the browser, and I share the tab like you're saying right now, it gives me the option to also share a tab audio. So I can confirm right now.
Oh, great. Yeah, and Brave is. I think it is uses Chrome, so it's just
Yeah.
yeah. Let's try it out.
Okay. I'm gonna put play right now, and you just let me know if you can listen or not listen.
Just dive right into this. Welcome back,
It works.
everyone.
Yeah.
Today, we're doing a deep dive into
Great. Okay. Um,
Great. So why don't you that works well. Yeah. Why don't we start with the very first video because that's an overview of absolutely everything we're going to be doing, and then we'll do the second
Welcome
video and
to
third video, and then we'll have a shorter discussion today.
okay, so before we start, if possible, because I didn't go through, I think I got it until video 8 while I was working and just as background noise, and I got the the idea, but it would be interesting if you can give a 30-second summary of what these videos are gonna go about, just for posterity.
Well, so my hope is that we watch the videos, then we you can explain what it's about, and if not, then we need to redo the videos. And so I think you not getting from the video what it's about is that's the critical information where you're missing. So are you okay with that strategy? Because I think it's really important where you go, okay, I don't really know from this video what's happening, or you paraphrase and it does make sense, but we really want the videos to make sense. So if I contextualize it, have it make sense, and you watch the video and we won't know if somebody's
Got
a
it.
audience. Yeah, that yeah, okay.
Okay. Yeah, yeah, yeah. I agree. Um, wait. So let's just do something here. Wait a second. Okay. So I'm gonna play now.
today's explainer. We are jumping right into a really fascinating curriculum called CLEAD, or Computational Legal Ease. It's a 14-week, 8-module program that's designed to fundamentally change how lawyers and law students interact with modern technology. For decades, the legal profession has operated almost entirely on natural language. But today, we're exploring a curriculum built specifically for legal minds, people who are already brilliant at logic, but maybe just aren't familiar with programming grammar, syntax, or computer science design. It is a massive leap, but honestly, an incredibly exciting one for anyone ready to bridge that gap. So, here is our roadmap for today.
First up, we'll look at the runtime mindset shift. Second, translating grammar to code. Third, loops and the Unix philosophy. And finally, we'll zoom out to look at the macro evolution of law.
All right, let's kick things off with Section 1, the Runtime Mindset Shift, which covers the first 2 modules of the curriculum. The very first goal here is to get over the biggest hurdle for legal minds, which is ripping up the idea of a document as just a fixed, dead piece of paper. Now think about what runtime actually means. It is so fascinating how this concept bridges a core legal idea, the performance of a contract, directly to computer science. In law, a contract dictates the performance that's required by the parties, right? Well, in computer science, a runtime is the actual dynamic execution of those coded instructions. By connecting these two, you can start seeing legal frameworks not as static rules sitting on a desk, but as active running systems. It's kind of like being a music composer. Instead of just writing a static page of sheet music that gets filed away in a drawer somewhere, you're designing a whole system beforehand. You hit play, and you actually watch the stage performance execute dynamically from start to finish. The curriculum calls this the calculus mindset. You're building an operational machine with verses and looping choruses rather than just filling up a page with text. And what's wild is that our modern tech landscape is already deeply intertwined with these exact legal principles. Take Charles Goldfarb, for example. He's often called the grandfather of the internet. He literally created markup language just by digitizing traditional legal redlined drafting techniques. Or look at Nick Szabo, who designed smart contracts. He did that by recognizing that the fundamental legal requirement of consideration could actually be hard-coded to incentivize decentralized network validators. Our whole digital world was heavily influenced by legal engineering right from the start. That takes us right into Section 2, translating grammar to code. Modules 3, 4, and 5 are all about building that grammatical bridge from natural language logic over to programming syntax. Because once you adopt that calculus mindset we just talked about, you actually have to learn how to read the new language. The crucial shift here is recognizing basic data primitives. In a standard legal document, the rules and the raw facts are all just mixed together in these dense, heavy paragraphs. But in programming, you have to strictly separate the logic of execution from the raw data itself. You have to categorize that material. Is it a string of text, a numerical value, or a true or false Boolean state? To make this super concrete, think about how a single word behaves passively inside a static Google Sheet cell. It's just sitting there. Now, compare that to how that exact same word behaves as an active, firing instruction inside a JavaScript code block. Context is absolutely everything here. It's vital to grasp when data is just waiting to be read versus when it's actively telling the system what to do next. And this module tackles a massive grammatical hurdle for lawyers. We are so hardwired to read natural English from left to right. But in code, an equal sign often means association. It means taking a value on the right and assigning it to the variable on the left. That is an entirely different mental muscle than reading left to right to ask, hey, do these two things equal each other? And when you start making these translations, it's amazing how standard legal clauses and subclauses just collapse perfectly into nested conditional logic in code. We're basically taking that classic if this, then that structure that's hidden inside dense legal jargon and stripping it all the way down to its deterministic skeleton.
Now, here is why this is so important. In traditional drafting, lawyers often use intentional vagueness as a feature, right? But that simply breaks when you force it into the strict binary requirements of code. When you write and or in a paper contract, human interpreters can argue about the context later. But a machine cannot do that. This module really forces students to confront how scope ambiguities completely fall apart in a deterministic Boolean environment.
Which brings us smoothly to Section 3, Loops and the Unix Philosophy. This covers Modules 6 and 7, and it's where we get into the actual mechanization of legal logic. In everyday legal prose, repetition is rarely made explicit. A contract might say, for each month, the tenant shall pay, but it doesn't actually loop programmatically. By introducing the concept of for loops, lawyers can suddenly mechanize and automate these legal performances. By understanding loops, you can take highly repetitive processes and automate them without manual intervention, which drastically reduces societal transaction costs.
And that concept naturally introduces contract chaining. Traditional contracts are usually these sprawling, all-in-one monolithic documents, but in a computational model, they act exactly like modular software dependencies.
If a foundational clause, let's say an overarching payment condition, fails to execute, then every single downstream agreement that relies on it instantly breaks. It's literally like pulling a foundational Jenga block from the bottom of a tower. This modular thinking leads us to a brilliant, classic principle from 1980s computer science, the Unix philosophy. The idea was simple but powerful. Write small programs that do one specific thing incredibly well and have them communicate with each other via simple text streams. The big takeaway for you here is that designing future-proof legal tools means relying on simple text-based pipelines. Whether you're interacting with advanced AI chatbots using natural language prompts, or you're standardizing legal records using clean JSON data formats, text is still the undisputed universal interface between machines and humans. Grasping this is what makes a legal engineer truly future-proof.
Finally, let's wrap up with Section 4, the macro evolution of law. This is Module 8. Now that we have a handle on the tools, we have to ask, how does this reshape the entire legal industry?
Well, we can actually map this trajectory perfectly to the evolution of transportation. We started out with direct law, the manual, analog, horse and buggy era of traditional lawyering. Right now, we're navigating mechanized law. We've introduced cars running at hyperspeed, which massively increases efficiency, but it also requires totally new regulatory guardrails, just like how cars needed speed limits. And the final destination? Automated law. The Waymos of the legal world, fully autonomous, self-executing systems.
So as the industry goes through this shift, two distinct career paths start to emerge, and the C-Lead curriculum sets you up for both. You might lean heavily into the engineering side, becoming something like a highly specialized patent agent for software architecture. Or you might decide to stay on the traditional lawyering path, but as a practitioner whose daily go-to tools are code and algorithmic logic.
Because here is the undeniable truth presented in this curriculum. Whether you become a hardcore legal engineer or just a highly tech-literate lawyer, your daily practice is going to fundamentally change. Why? Because your deliverables are turning into code. The end product of legal work is no longer just a static PDF. It is rapidly and inevitably evolving into functional, executable software.
So I'm going to leave you with this provocative thought. As your own legal deliverables turn into software, how are you going to adapt your mindset to ensure you aren't left driving a horse and buggy in the new age of autonomous law? The C-Lead curriculum really provides the roadmap to become an active architect of these systems, rather than just a passive user. Thanks so much for joining me on this explainer, and I really hope this deep dive into computational legal ease has sparked your curiosity about where this profession is headed next.
Okay. You got the. I hadn't noticed the Gemini notebook at the end, but
Yeah. And this next video we'll be watching will be then about the next couple of weeks of what we'll learn. So that was about the entire syllabus, and then I shared a link with you in a Telegram that is the syllabus as a document. But let's see before you look at that what you can grasp from that video. It's not that difficult to make new videos, and I expect us to have the final versions of videos be an improvement to this first round. But yeah, back over to you on what your assessment is of why we're doing this and what we'll get out of it.
related to the first video, or you want me to put the second one?
Let's stay with the first video for now, because that's for the entire syllabus. And then you've got that document off screen that you can also see what's going on with the entire syllabus. But yeah, let's have a conversation about what you think this entire curriculum, this whole semester is about.
Yeah. So I grasp the general idea of learning to transition from traditional law and the sense of obligations and all the rights and yada yada that lawyers have been reviewing with time, and transitioning that to coding in the sense of automating everything within the contract. And it could be better said, but what I took from it is, as all this technology it continues to evolve and grow, and give multiple solutions to very old problems, humanity needs to transition and evolve with it. So when we have a contract, and that is one of the thought-provoking things that happen right now, is when we have a contract that is, I don't know, an obligation to do, it turns into an easy follow-up journey into saying, well, I delivered the card, now pay me, in a very ample sense. But the thought that occurred to me was, what happens when those elaborate and difficult contracts with multi-steps and multi-stages in a contractual relationship, is this a good fit for that kind of engagement as well? And so when we transition from PDF contracts that state that X will do Y in consideration of value Z, okay, good, and that's good enough. And that will work, and that is where we will transition from a horse to a car, and 100%. But then I'm curious to see what is the solution for contracts. I don't know. Let's say a very complicated solution of a uh, M&A with a trust structuring behind it and all the taxations and that kind of complicated engagement. Where is this going to lead to?
That was well put. Um, I, to me, that seems that video did a pretty good job then. And I mean, I've watched future videos, and I know what the curriculum is, so a lot of your questions, well, the syllabus will dive into those. But also, I mean, from my perspective, you seeing that there are places where you have curiosity, and there's places where you understand what it will offer. That's a really good sign. I guess for someone who's not so acquainted with this, do you think the horse and buggy to car narrative is sensible, or because you already somewhat bought into that idea, you're already sort of primed for that, and we might find that for other people, we'll have to contextualize more why this is something they should focus on and care about.
Yeah, so that's a really good point you bring up, because somebody who is not from a legal background, and I never know if it's technological, or what term it is best to describe, but from the technology curiosity perspective, these kinds of questions may be, I don't even know how to describe it right now. But I think it is a conversation that people need to have, just because that is where it's going to be headed. It always comes back to the example of the vending machine, where a vending machine, you used to be able to click Pepsi or Coke or Fanta or whatever juice you want to order, and then you pay with cash or card, and then the system gives you whatever you ordered. Sometimes it didn't, sometimes it did, sometimes it gave you a double product, and then you grabbed it, and it's signed and done. And so whenever I see these videos and these kinds of conversations, I always compare it to that, just because that is going to be the next iteration of contracts. You are going, and it's already happening also with e-commerce and among other things. You're just going to have to click I accept on a specific thing, and everything is going to happen in the background for it to arrive to your door, right? I don't know if it's also compared or a viable example.
That's great, and I don't know if you know this, but Zabel, he thought of smart contracts with the vending machine mental model, and then when I first entered the space, I didn't know that, and I did that as well. And people who were in conversation with me, they did have that understanding, and I remember them having a reaction that I settle on the exact same mental model, and it is really useful. And we can also think now that I'm thinking with robotics about how a dishwasher is a robot. So what was it, Mark Cuban recently said, I don't think they're going to be bipedal robots so much in the house. I think they're going to be unusual shape that fits the house, just like there's a cupboard now for the disc robots that do the vacuuming. And when I sat with that, I realized, oh, wait a second, that really explains already that we've had robots for decades. Because what is a dishwasher other than a unusual shaped robot? And the note there is consideration. So Dable added that element in robotics or mechatronics, or however you want to call it, because computers will do that work for free. They don't expect any consideration. And so adding that extra aspect. And then we know that there's washer and dryer machines you can put a quarter in, and then that is a kind of vending machine. So I definitely agree with you there. I like where your mind is going. And I do anticipate that now with agentic systems, the legal community this is the inflection point, that we don't have to convince so much, hey, there's a big shift happening. There's actually a lot of anxiety. How do we handle this big shift? And a few years ago, we might not have had so much buy-in. I mean, we'll still have to do customer discovery to determine if that's actually true. But that's a good signal for now that this is sufficient context that people will know why they care about it. So why don't we jump into unless you have other comments, why don't we jump into this next video?
Yeah, no, okay.
Welcome to this explainer. Today, we're going to completely rewire how you look at legal documents. We're unpacking the first 4 lessons of the C-LEAD curriculum, which stands for Computational Legalese. Now, if you're a law student or a legal practitioner, you know you already have absolutely world-class logic skills. But you might just be missing the programming grammar, the syntax, and those system design principles required to actually apply that logic digitally. So today, we're going to bridge that gap.
So what actually happens when paper contracts come alive? I mean, think about it. For centuries, the legal profession has relied on written, natural language to express agreements, right? Just static documents sitting in a filing cabinet somewhere, just waiting for a human to pull them out and interpret them. But today, we're moving away from that world of dead, static paper and stepping directly into the incredibly dynamic realm of legal engineering. We are translating paper-based legal obligations into active executing code. I really want to let the weight of that sink in for a second. It's a massive paradigm shift from dead text to living systems.
Here's our roadmap for today. Number 1, the meaning of performance. Number 2, software runtimes explained. Number 3, the composer metaphor. And finally, number 4, lowering social transaction costs. Let's just jump right in.
Starting with Section 1, the meaning of performance, fulfilling obligations on paper.
Okay, so in the familiar territory of traditional law, a performance is pretty straightforward. It's simply a human party fulfilling their contractual duties exactly as they were written down on paper. When lawyers draft a contract, they're essentially writing out exactly what performances the party should fulfill out there in the real world. It's literally an instruction manual for human behavior. But historically, ensuring that performance actually happens, well, that requires a lot of manual oversight. Every single time an obligation is met, a human has to verify it, they have to record it, maybe chase down a payment, and sometimes even argue over the whole thing in court. It's just a very slow, high-friction process.
Moving along to Section 2, software runtimes explained, the execution of instructions. Now, in the tech world, a software runtime is the active, dynamic execution of code. Basically, it's the computer autonomously fulfilling its programmed performance from start to finish. I want to pause right here for a second, because this conceptual link, it's the core insight of this entire explainer. A contract outlines a performance, and a runtime literally is a performance. Recognizing that law and computer science are actually talking about the exact same fundamental concept is absolutely key to getting into this mechanization mindset.
Just look at the incredible contrast here. In traditional law, you read a static document sequentially, right? Left to right, from the top of the page down to the bottom. But to really engineer law, you have to shift your brain toward more of a calculus mindset. Because in code, an active assignment executes from right to left. Imagine assigning a variable in a program. The computer figures out all the math on the right side of the equal sign first, and then it pushes that final solved result into the container on the left. You aren't just looking at flat text anymore. You're looking at an active machine lever that calculates and executes actions directly on a distributed database. You know, you might not realize this, but our whole digital world was actually architected by pioneers who translated traditional legal drafting directly into information technology. It is truly mind-blowing. Take Charles Goldfarb, often called the grandfather of the internet. He created markup language, which of course became the foundation for HTML, by directly digitizing traditional legal red-line drafting techniques. That single legal engineering translation helped birth the entire multi-trillion-dollar internet economy. And decades later, Nick Szabo designed smart contracts by taking the fundamental legal requirement of consideration and literally hard-coding it into programming language. By injecting that legal concept, he created the exact incentives needed for decentralized network validators, which is what gave us the distributed databases we all use today.
Which brings us to Section 3, the composer metaphor, designing before play.
To really grasp this new dynamic without getting completely bogged down in technical intimidation, I like to think of a musical composer. A composer meticulously orchestrates verses and looping choruses way before the concert ever begins. And a legal engineer operates the exact same way. You design the contract's logic before ever hitting play to watch the software runtime execute. In traditional law, repetition is almost never made explicit. A lawyer might use a phrase like "for each," but they don't naturally think in programmable, automated loops. A composer, on the other hand, knows exactly how many times a chorus is going to repeat. In legal engineering, we map those musical loops directly to computer science for loops. You design the entire stage performance, you press play, and the runtime just executes the logic autonomously over and over again.
And because we're engineering law like a software system now, we can start thinking modularly. Instead of a giant, intimidating stack of paper on a desk, imagine an intricate, glowing flowchart of dependencies, like digital gears turning one another. This is known as contract chaining. By engineering law in this modular way, if a prerequisite contract or a payment breaks, the entire downstream permission chain breaks automatically. If you modify a single boilerplate indemnity clause somewhere in the system, that one change can instantly cascade down to update every downstream agreement that relies on it. It completely transforms abstract, isolated legal relationships into a highly organized, instantly reactive structure.
All right, final section, number 4. Lowering social transaction costs, the macro impact.
So why go through all this effort, right? Why turn paper into code? Well, because we are rapidly evolving from the slow, high-friction horse and buggy days of traditional analog lawyering and moving directly into the Waymo era of autonomous, self-executing systems. Just as mechanizing transport allowed humanity to move faster than the speed of a horse and totally unlocked modern global trade, mechanizing the law is going to fundamentally reshape our entire economy. It is literally an upgrade to the operating system of human commerce.
Translating paper obligations into active code just obliterates massive amounts of human friction. In traditional law, vagueness and ambiguity are sometimes, considered a feature. It gives you wiggle room. But in code, a single missing semicolon breaks the whole system. Computers demand strict Boolean logic, meaning absolute true or false conditions. There is no maybe. By mapping contracts into this nested deterministic logic, we completely eliminate manual execution delays. When the runtime executes, the performance is mathematically guaranteed. This hyperspeed, deterministic execution drastically lowers societal transaction costs, and it allows markets to operate at a scale and speed that paper contracts simply could never, ever support.
And this isn't just some abstract theory we're kicking around. This is about your future. The macroevolution of the legal profession is splitting right now into two very distinct paths. On one path, you've got developers who will start acting as specialized legal authorities, actually very similar to how highly technical patent agents operate today. And on the other path, traditional legal practitioners are going to naturally adopt programming syntax. Why? Because their daily deliverables are no longer just static PDFs sent over an email. They are compiled, self-executing software dependencies running on distributed global networks. As we shift from static paper documents into dynamic software runtimes, the very mechanics of our society are being fundamentally rewritten. So I'm going to leave you with this final thought to kind of chew on as you navigate your career. Are you going to just sit back and watch the runtime execute like a passenger? Or are you going to be the engineer designing the code? Thank you so much for watching this explainer, and keep learning.
All right, let's just...
I like that one.
Oh, great. So yeah, it's still higher level because it's describing, I think, 3 weeks of materials, but does it? Well, you said you liked it, so what were the reasons? Yeah.
I like it because it explained, like we were talking about in the last video, what would happen if it's a multi-stage, multi-sequential engagement between two or more parties. And it didn't, it first off, I appreciate it that it's very clear, very direct, very digestible um, explanation. Um, while reading along with the captions, it just made sense. And so we were saying in the first video, how do you get it if it's a more complicated thing? And right now, I think we got the answer. It's just going to turn into um, a process of sorts where everything is going to be. Maybe I'm not using the right terms, but it's going to be sequential, automated, and reactionary based on XYZ metric. And so I like the part that it said it removes the manual human component or manual social component, I think it says, which for me was also something that I identify always in processes is the human factor that just has a hard time following instructions or being disciplined. And so I think the start of the answer was there, obviously subject to more details. If one of the only comment or feedback, if you will, but I think it's very subjective, very personal, and it's not of a general feedback. I would, if how do I say this? If this explanation can be guided towards a case example so that it continues to evolve throughout the explanation. So at the beginning, we had the horse to the car comparison. And so maybe the transaction could be just the purchase of a house. And then right now with this second video, you explained that it has other components, other steps, other parts of the process. And then so the purchase of a house, it has a loan included in it. So it's now on a separate tangent. And so next video, I don't know what's going to be. What is performance in law? Okay, so that's the delivery of the house, and the contractor is saying that the wall is white, but the wall is yellow, and all those kinds of things. That like it would be interesting to see how a very simple case can turn into something so monstrous, like the lines we are seeing and the whole hierarchy of processes. But again, that's just me as a way of thinking on how these concepts evolve.
That's really that's a lovely suggestion and insight, and my hope that with you having this fresh look at it, that you would have those kinds of insights make me quite happy. So yeah, the case study method and that's, we don't do that so much in law school, but business school, I think it was Ivy and Harvard that pioneered the case study method. I love it. So let's consider what a case study that we can continue on throughout the syllabus will be. A real world asset type of case study is very sensible. And we'll add that to next season's curriculum. I mean, we can also, if we feel like we have the cycles upgraded this season, but I don't off my mind know the exact case study, and hopefully as we go through this, we can figure that out, and then that can be prepared for the next one. But that will definitely ground it for people and have it be very practical. So unless you have other comments in the interest of time, because I know we're already over, let's do this final video and then we can hear your comments, and then we can call it a day.
Okay, sounds good.
Dive right into this.
Welcome back, everyone. Today, we're doing a deep dive into a paradigm shift that is, quite frankly, completely rewiring how we think about the entire legal profession. We're unpacking the foundational concepts of the Computational Legalese curriculum, or as you'll hear it called, CLEAD. If you have ever stared down a 50-page legal contract and thought to yourself, there absolutely has to be a more dynamic way to handle this, well, you are in exactly the right place. In this explainer, we're setting the stage to completely shift our mindset. We're moving away from traditional static legal drafting and jumping headfirst into the incredibly fast-paced, dynamic world of computational law and legal engineering. We're going to fundamentally analyze how paper contracts actually express the required performances, the real-world obligations of human parties. So, here's our course syllabus for today. We're going to cover 1. The static paper illusion. 2. Defining legal performances. 3. The software runtime perspective. 4. The composer metaphor. And finally, 5. Reducing societal transaction costs. Let's get to it. Before we get into the weeds, I want you to hold on to a really provocative thought for the rest of our time together. Imagine for a second, what if a contract wasn't a document at all? What if instead it was a living, breathing performance? We are all so used to viewing legal deliverables as just the stack of dead paper sitting on a desk. But today, we're going to completely flip that preconceived notion on its head. We're going to show you the hidden, active calculus that is literally running beneath the ink. All right, Section 1, the static paper illusion. Let's look at how traditional lawyers actually view these paper contracts. Okay, so the status quo of legal reasoning has this deeply, deeply entrenched bias. Traditionally, law students are taught to view legal drafting merely as, words printed on paper. It's a natural left-to-right English reading style, right? But that style kind of lulls us into viewing these documents as static, dead things. And honestly, it's a total illusion. When you only look at the grammar and the prose, you completely miss the active nature of contractual duties. A contract isn't just some story you read before bed. It's a very specific set of instructions. It's this dynamic calculus of obligations that people must actively fulfill in the real world. Moving on to Section 2. Defining legal performances. We really need to break down the actual required actions of the human parties involved.
To ground us in something familiar, let's look at the word performance. In a strictly legal sense, performance is the act of fulfilling contractual obligations and duties between human parties. When we draft traditional paper contracts, what we're really trying to do is capture and express these required performances. We are outlining exactly what human beings must do out there in the real world. It's an active duty. It's the execution of a promise. I want you to keep that exact concept, active execution, front and center in your mind.
Which brings us to Section 3, the software runtime perspective. This is where we shift gears into the magic of the CLEAD curriculum.
We're going to introduce a foundational concept straight from computer science, which is a runtime. So a runtime in a software sense is the active execution of programmed instructions. It is that exact moment when the code actually comes alive and does what it was built to do. By defining a runtime, we're setting up this absolutely critical bridge between the world of law and the world of engineering. Once you grasp this, it completely changes how you view a static script. Now look at how perfectly these two worlds map together. It's kind of mind-blowing. A legal performance, the act of fulfilling human obligations, maps directly to a software runtime, the act of executing programmed instructions. Legal engineering basically takes the fulfillment of a legal duty and translates it one-to-one into the execution of a software instruction. We are fundamentally shifting away from static paper drafting and moving into a dynamic, executable mindset. We're teaching law students to see that fulfilling a contract and running a computer script are conceptually the exact same thing.
Let's look at Section 4, the composer metaphor. Getting a handle on these computer science principles can be a bit tough for legal minds at first. That is exactly why the CLEAD syllabus introduces this really powerful, intuitive metaphor to make the transition seamless. Think of creating a living contract like a musician composing a song. Step 1 is designing the system beforehand, just like a composer writing out the verses, the choruses, creating the loops. You are orchestrating all the logic before anything even happens. Then, Step 2 is hitting play. In our world, this is the equivalent of executing the code or officially signing the agreement. And finally, Step 3, you get to sit back and watch the stage performance execute from start to finish, completely autonomously. It's a chronological flow. You aren't just writing a dead document anymore. You are composing an automated stage performance.
Now let's zoom out for a second and look at the macro evolution of the legal profession. We can actually view the evolution of law through the lens of transportation, which I think is super helpful. In the 19th century, we had analog or direct law. This is the horse and buggy era of traditional lawyering. Fast forward to today, the 21st century, and we're in the era of mechanized law. Think of this like the invention of the automobile. It introduces hyperspeed, for sure, but it also requires brand new regulatory guardrails, just like cars created modern negligence torts. And looking ahead to the future, we are rapidly moving toward automated law, the equivalent of self-driving Waymos, utilizing fully self-executing systems. Careers, deliverables, the whole shebang. It's all evolving rapidly right along this timeline.
Okay, our final section, number 5. Reducing societal transaction costs. We've talked about how contracts are runtimes and how the profession is evolving, but why? What is the macroeconomic why behind this entire curriculum? Well, the overarching objective of everything we've unpacked today is simply this. Mechanizing and automating legal performances fundamentally reduces societal transaction costs. That's the real game changer. The goal isn't just to use shiny new technology for technology's sake. No, the goal is massive societal impact. Shifting from paper to software literally removes the incredibly expensive manual friction that slows down human progress.
To really drive the punchline home here, viewing contracts as active runtimes makes society vastly more efficient. When you mechanize the law, you cut out those horrible paper-based bottlenecks. You turn static legal logic into a high-speed digital reality. I mean, just imagine a world where contractual performances don't require literal armies of administrators to verify and execute every little detail, but instead, they just run autonomously, like perfectly composed software. That is the true promise of legal engineering. So as we wrap up this explainer, I want to leave you with one final provocative thought. Take a look at your own work. Literally, look at the document sitting on your desk right now. How are your own legal deliverables going to evolve from static paper into active software? It's time to start applying this calculus mindset to your own practice. The future is an active runtime, and honestly, it's time we all learned how to hit play. Thanks so much for joining me today, and I'll catch you on the next one.
Cool. I think this video was felt almost like a recap of videos 1 and 2. I don't want to say repetitive because that's not the right word, but it brought back concepts, imagery, and comparisons that we saw in videos 1 and 2. So it was a good solidifying ideas and just making them stick. That was my general impression. No takeaways, no new takeaways at least. Just nodding along.
Great, and something we can think about as well is watching 3 videos in one session is probably too many. So
That's also,
great.
yeah.
Yeah. The spot that you know. Sorry, over to you.
Yeah. Yeah, definitely. I mean, they're good short videos. It's manageable. Yeah, that's the general comment.
And something we can do for future classes is say outside of the class, watch the videos that are this introduction on why would you watch the videos at all, and then if you want these every month on your own, watch the class that explains what's going to happen the next month, and then in class we just watch that one video for the class. So these additional ones, we also can leave them out, but I like the idea of them being supplemental, or something that we don't all sit together and watch and then discuss. There are ways that people can get themselves, people who want to be more contextualized and oriented before classes start. There can be a way to have them do that. So the one video we watch, everyone's really fresh and all those thoughts are connecting as much as possible. What are your thoughts on that strategy in the future?
I 100% agree with that, because one of the things in the past iterations of Lex Clinic was that it was too much of going and figuring out what, like, it was too much novelty in too much of a short period of time. And so, yes, there was an agenda, there was a curriculum, and everybody knew where it was headed. But it's definitely better if people can have a source of preparation just before the call. Um, and I mean, if people don't want to listen to it, if they don't want to listen to it, it's up to them, because otherwise you're just going to show up to the Lex Clinic call to try and catch up. It's also better for you to get the message through, because otherwise you would be explaining, but maybe most of the time or sometimes some ideas wouldn't go through just because it was very easy to get lost if you didn't know the background or the context of that conversation. And finally, that said, are you able to, I mean, are these videos generated by Gemini Notebook audio files that you then put on top of a video, in the sense of, if I can get access to that audio file, maybe we can create a podcast profile or a Spotify profile and upload the audio there as well? Because I would personally take the opportunity in the train or the bus to start listening to them and be taking notes on my daily life.
Yeah, I mean, a lot of these videos, I mean, not this series, but other videos, I've only listened to the audio, and I guess I have YouTube Premium, so that's different, because with YouTube Premium,
Yeah.
I can just shoot the video and then cut off my screen and then just use it as an audio file. I
Yeah.
definitely can, and I will, from your comment, generate a whole audio series. Those tend to be a bit longer, but when people are traveling, that's the better format. I mean, it's a bit longer, and there's no pictures, so a lot of the content has to be personalized. So I'll ask Agent tonight to generate a set of audio that I'll figure out where to publish it, because YouTube problem, it won't fix it. We can also, if we prefer the video from these, or from an audio from these videos, we can only just extract the audio only. That's really straightforward. But the main concern is somewhere to publish it, and that setting up the Lex Clinic's website, that seems to be a reasonable way to get that done anyway, because it's not that much effort. That's ready for next week. I don't think there's a rush here, so let's have that as the plan right now. There's also, I would say, outside of the, and that might be what we want to do outside these clinic classes, looking at these supplemental videos, you and I, so we can still have your fresh take on it, but it's not what we plan for the classes with the students, because it's supplemental. On top of it, I've done 4 videos on the behind the scenes on how this was made, and the fact that we have that really disorientating period is where we as educators, that's what I want us to continue to do for future sessions, and because that what I'm calling dithering is how we got to this point where hopefully this is a syllabus that makes a lot of sense to everyone. And the redundancy, you'll see, I've asked the agents, why did you do certain things with such repetition? And it was because of our experience together. So me jumping ahead because I have this knowledge I didn't realize it would be counterintuitive for lawyers. So one you'll see in these future videos, there's it really focuses on what association is, or assignment, different than equals. And because that single equal sign compared to the double equal sign, I just glossed over that. I didn't think that was really a matter, but I really appreciated these videos because they, I think, better highlighted why that was so difficult.
Mm-hmm.
And if they continue to do a really great job, they'll have that extra knowledge base of education that they'll have that patience. So, for instance, I don't think I ever said, "Oh, you have to read not left to right. You have to read right to left." I don't think even it. So I thought it would take one session, and ended up taking us 5 or 6 sessions. And I don't think even in those 5 or 6 sessions, I really highlighted, "Oh, you have to read in the other direction." And that's the problem here. We're naturally reading right or left to right, but actually with coding, you need to read left to right. So I think that's when you go through the syllabus and there's that redundancy there. Now you've already spent time and kind of rewired your brain, and potentially law students, they will not have to rewire their brains, but definitely CLE, continued legal education, and having practicing lawyers know what's happening. That's where the biggest hurdle will be. Will actually be to have to get them to change their thinking from what they're really used to, and that's baked in. And so for future curriculums that we make, I do expect us to have, that's where we earn our professional abilities, is that we're willing to take that extra time for those 5 sessions, and we can then compress into one for the end product, and that's kind of the raw materials that we deal with. Whether it's us or other people that are making educational materials, and those behind the scenes videos, they explain that. One comment I wanted to note was recently with chatting with Cahill and Harris saying, well, the bylaws are not ratified yet, so they're a living document, and then when they're ratified, that was an interesting comment from them, because as this curriculum says, it's thinking that text, static or dead document, what have you, is going to become a living document. But from Harris's perspective, if it's convention and it's not ratified, it's not written in stone, then that's what a living document is. So that right there is something to note, that there's already a communication difference here, because, and hopefully that runtime, what the runtime is, that will be reinforced, will help explain how we're taking this living three concepts in Canadian constitutional law and textualism in U.S. constitutional law, and marrying them and finding a synthesis of them. But we might also find that calling this stuff living documents, we might want to use a different vocabulary entirely. And that's where I think when lawyers are really dogmatic and stuck in their ways, and we think, why can't you learn this so fast? We'll be wiser at recognizing there might be some decades long of modality that is really reinforced with them, and it might be easier to reframe it in something that is really novel. My personal experience, I think of that as when I was younger and I was learning a second language. I started with Spanish, but because Spanish and English are so similar, I was getting caught up in using English rather than Spanish. And so switching to Japanese was easy for me because it was so different. I didn't have my preconceptions confusing me. Now as an adult, it's much easier to deal with Spanish than say Japanese, because I can pull from my existing knowledge base. But it's a trade-off on whether being familiar with something that's different is helpful or a blocker.
Yeah, I can see that. I can see it resonates. But yeah, we can continue next week. I'm gonna modify the calendar invite to, I would think 45 minutes would be ideal, and it can run to an hour. But do you agree with that time slot? Because the last time we were doing 1 hour, they ran for maybe hour 15 sometimes, and that felt kind of it was very demanding, because these topics of conversations require a lot of brain exercise, right? So I think 45 minutes plus 10 would be ideal, and then we can start inviting people and start phasing this out.
That sounds good. And and just doing one video and making sure that's what we do, and these other videos people can watch them beforehand. That also help be in time. It was just you this time around, but Robert should be joining, and he often has a lot of thoughts. So one video, but adding Bob 45 minutes seems reasonable. And if we just find out we're 30 minutes, we get that 15 minutes back. But if we go over 15 minutes, yeah, it doesn't seem like we're going over twice the time. So that's a very good suggestion.
Yeah. Okay. Let me just do that right now then. So Lex Clinic is. And then you said Baba is gonna be joining us, so I'm gonna just send him out the invite. Who else do you wanna send an invite to?
I think that Telegram group is fine for now. This class, I don't think we need to open up to a wider audience yet, because this is still experimental. So I'm fine with a small group of just a handful of people. So if Robert joins initially, that seems sufficient, especially because we've got a lot of administrative work to do with the clinic that will take up our cycles. And so yeah, no need to try to get do the cycles of broadcasting. That's more. And I also think what I want to do is for the fundraising is a lot of that will go into marketing. So then we just added the way to get the word out. And so, yeah, so this is good. We don't need to try to grab a much wider group of people. Keep it a close held still. And those videos are public there. So people who are thinking of donating, they can see what they're donating to. So they'll have some visibility.
Okay. Well then, see you next week then.
Thank you. Yeah, see you next week.
Thank you, Kyle. Okay. Wait. Stop recording.